Hello friends, in this video I'd like to solve the following problem from the Estonian Mathematical Olympiad 11th grade final round 1996, problem number 4. So we wish to prove that for each odd integer n greater than or equal 5, the sum 1 to the nth power plus 2 to the nth power and so on up to 15 to the nth power all is divisible by 480. So my hints for this problem, first of all, factorize 480 and then use modular arithmetic, modulo every every factor of 480. So I hope that you tried it. First of all, it's very easy to see that 480 is 23 times 3 times 5. So it suffices to show that our sum is congruent to 0 modulo 3, modulo 5 and modulo 32. So let's first consider modulo 3. 1 to the nth power plus 2 to the nth power plus 3 to the nth, 4 to the nth plus 5 to the nth, 6 to the nth, 7 to the nth, 9, 10, 11, 12, 13, 14, 15. I will copy it to save some time next time. Okay. Let's see. 1 to the nth plus 2 to the nth, 3 to the nth is congruent to 0, then 1 to 4 is congruent to 1, 5 is congruent to 2, 6 is again congruent to 0, and so on. We see the pattern. And here we see that it is in fact 5 times 1 plus 2 to the nth power. And since n is odd, 2 to the nth power is congruent to -1 modulo 3. It's easy to see that 2 to the nth power alternates. It's 2 to the power of 0 is congruent to 1, 2 to the first power is congruent to -1, 2 to the second power is again congruent to 1, and so on. It alternates, which implies that our number is congruent to 0 modulo 3. Okay. Now, modulo 5. Again, let's consider our sum. Let's see. 1 to the nth power is congruent to 1. 2 to the nth power is congruent to 2. 3 is congruent to -2 to the nth power. Then 4 is congruent to -1. 5 is congruent to 0. And the pattern repeats itself. How many times? 3 times. It repeats itself 3 times. And again, since n is odd, it implies that -2 to the nth power is, or maybe that it's congruent to -2 to the nth power, and -1 to the nth power is congruent to -1. So again, we see that this whole sum is congruent to 0 modulo 5. So we have divisibility by 5 as well. Finally, the most interesting part, modulo 32. Modulo 32. Okay, so first of all, since n is odd, write n equals 2k plus 1, where k is some natural number. A natural number is an integer which is greater than or equal to, because n from the assumption is greater than or equal 5. What happens now? What happens now is that, let's see, first of all, 2 to the power of n is 32 or higher. 32 or higher power of 2 is congruent to 0. Similarly, this number is also congruent to 0. This as well, as well, here also, and here also. All these numbers are congruent to 0 modulo 32. So we are left with only powers with odd bases. And now 1 is 1. 3 we will write 3 times 9 to the power of k. It's pretty easy to see that it's the same. Then we have 5 times 25 to the power of k, 7 times 39 to the power of k, 9 times 81 to the power of k, 11 times 121, 13 times 169, and finally 15 times 225 to the power. Okay. And now we will group our numbers. First of all, we will reduce modulo 32. First numbers will stay the same, but here 49, it so happens to be congruent to 17 modulo 32. 81 is also congruent to 17. 121 is congruent to 25. 169 is congruent to 9, and 225 is congruent to 1. And now let's group our terms. Here we have 16. Here we have 16 times 9 to the power of k. Here we have 16 times 25 to the power of k. And here we have 16 times 17 to the power of k. We can put 16 in front of the parentheses, and we have 1 plus 9 to the power of k plus 17 to the power of k plus 25 to the power of k. And now it should be visible that this number in parentheses is even. It's even because we have sum of 4 odd numbers. So we have 16 times some even number, so it is in fact congruent to 0 modulo 32. So combining these three results, we have already shown that 1 to the nth power plus 2 to the nth and so on is congruent to 0 modulo 3, 5, and 32, which means that for every odd integer, greater than or equal 5, our sum is in fact divisible by 480. Which was our goal. So this closes our proof and closes our video. So thank you for watching and see you soon.